So, group 7 are halogens. Group 7, of course, are the other end of the picture. Last week we looked at the alkaline metals. They're all really reactive metals that we looked at. These are halogens. So what's the first halogen, the top one in the periodic table?
Chlorine.
Fluorine, followed by chlorine, bromine, yeah, and acetylene. Oh, acetylene. Okay, so those are our first one. Now, those are how we would write their symbols, but if we write them as in equations or so on, they are all diatomic, and we say they are diatomic molecules. So whenever you write them in equations, you always write them with a 2 after. So F2, Cl2, Br2, I2, or AT2. What type of bonding is going to be in that molecule? What type of bond is going to be between two fluorine atoms? Why covalent? Two non-metals, so they always share electrons. So let's try and just draw out what they're fluorines. So you may just want to make a little diagram of this. So if I've got two fluorines, I'll just do the outermost shells. How many electrons has fluorine got, or any of the halogens got? They've all got 7. Why 7? What group number are they in? They're in group number 7. So I draw two fluorine molecules. If I do crosses for this guy, that's 6, 7. Circles or dots for this guy. And then that there is a covalent bond. And how do you define a covalent bond? Shared pair of electrons. So you've got a shared pair of electrons. That's your covalent bond. And we draw, if I was just to draw it, I could do it as a little line, like so, as well. So it's always the same. So you can draw it, and this is showing this shows the outer electrons only, which they're often happy with when you do that. So you could draw any of these, just showing the outermost. So if they said draw iodine, you could just, if it's just outer electrons, you just change the F's to I's. It's really easy peasy. Now their colours we're now going to come and look at, because they're quite colourful molecules. So should we make some the first thing we're going to do is we're going to make some chlorine, because obviously we don't have chlorine knocking around. So I've got some HCl here, because there's HCl, potassium permanganate there, and I'm hoping that as I add it, can you see I've got green gas being produced over there? And hopefully, I don't know if you can pick up, but I've got green. Could someone grab me a bit of white paper? White paper. Oh yeah. Okay, so can you see, if I put the white paper there, I've got a green gas appearing? These guys can see that.
Yeah, we've got the iPad.
No, you can't see it. You can.
Yeah, so you've got a nice green gas appearing here. So I can try and trap that in. So the only reason I'm going to do it this way is because obviously I don't have a cylinder of chlorine gas knocking around the lab. But we've got a nice place. So this is what we used last week when we reacted with the sodium, right, just generated it. So that's my chlorine gas. I'm going to try and add a little bit more. So chlorine gas is like a pale green, what's the gas? Pale green gas. So you need to know the colour of chlorine. Okay, so let's get that chlorine done. Right, bromine you need to know as well. This is bromine. Again, they're quite nasty. When you use it, you're going to be using it in, can you see that's actually fuming? As I took that off.
Oh.
Okay, you can see the fumes coming off. It's quite a volatile liquid, but it's a beautiful colour. It's kind of like a very dark red liquid. Yeah. It's quite a nice, almost like a piggy bank that way. If I go on that one, as you see, I don't want to get this though. Stop playing with each other. And so that's bromine sorted. And then finally, we've got iodine. Iodine is a solid. So chlorine a gas, bromine a liquid, iodine is a solid. Let's have a look at this. Iodine's not so bad. It's like a shiny grey solid, like so. Can you see it's quite glittery? Yeah, you'll be happy. That's quite a shiny grey solid. So you need to know what they look like. Does anybody know something special about iodine in terms of the states that it exists in? What would happen if I heated this?
It goes straight to gas.
Yeah, what do we call it when it goes straight to gas?
Sublimation.
Sublimation, yeah. Sublimation, yeah. Sublimation is when they're like that. Okay, cool. So those are the states and the colours of iodine. Okay. So from that, the halogen, the colour and state, we know this. So chlorine is a pale green gas. Where it says halogen, the element, you could put the symbol. So should we do that? So element. Oh, actually, you've got this on. I've told you, so you're okay. So chlorine. How do we write chlorine? Is Cl2, Br2, and I2, and the colour and state. Chlorine is a pale green.
It has dissolved in water and dissolved in organic solid.
Yeah, we'll do that in a minute. Yeah. So don't worry about this, you've got this. Bromine is a dark red liquid. And iodine is a shiny grey solid. So, based on that, what do you reckon acetine would be?
A shiny grey solid.
Do you reckon it would be grey? What's happening to the colours? They're getting...
Darker.
Yeah, darker. So acetine perhaps would be black, yeah. Black. What state would he be? State. I've gone from a solid. I've gone from a gas, a liquid to a solid. So he'd be a solid.